Okay, so we're going to try to walk through this absorption of radiant energy lab. We already did all the intro up here, the objectives, the materials. We actually set up everything, collected all the data, which really puts us down to starting really down here about number 9. So analyze the graph to determine the maximum and minimum temperatures, and then determine the slope of each graph, and then also export a PDF copy of the graph, and then either attach it to this assignment to the PDF copy or go back to Schoology and upload that PDF if you're doing a paper version of this. So this is for the NTID day on January 29th. So you have in the lesson plans here to finish the radiant energy lab, and I said the data is posted under updates. So if you click on that, you go down here a little ways. Should be one of these down here. Actually, this is all the classes. So if you're in second period, it'd be this one. This is first period. That's fifth period. But anyway, so it's going to be this file. Download it. And then we're going to need to open it. Now, you could use the version that we downloaded. If you're having issues with that, though, on the MacBook, you can do the online version as long as you're actually in Chrome. You could do this. So you can just click the online version link that we have there. Give it a second. It comes up to this, or should and come up to this. And then say open in browser. That should open a browser version of it, which looks very similar to the one we have offline. From here, you go to choose file. And then we got to find our file. So the one I actually uploaded was for fifth period, radiant energy, and it's this file right here. Yours will probably be in your downloads. So open that. And then it looks something like this. Okay. Now, let's go back to number 9. Analyze the graph to determine the maximum and minimum temperatures. So click the graph tools, choose view statistics, record the minimum and maximum temperatures for both probes in the data table, and then dismiss that statistics box. So we come back over here. You're going to go down to your graph options down here. We're going to click that. We're going to go up to view statistics. What that gives us here is all of our stats for the white paper and the black paper. Okay, so the white paper had a minimum of 22.031. We'll just round it off to 22.0. The white paper had a maximum of 32.0. The black paper had a minimum of 22.7 and a maximum of 42.9. Okay, so we need to go back to our data sheet. Scroll down here. If you're doing this on paper, you can just write this in. So let's make a text box there. And see the white paper, the minimum, 22.0. So just type that in. That's the white paper minimum temperature. Then the white paper maximum was 32.0. Okay, so put that in there. And then for the black paper, the minimum, 22.7. So we'll put our 22.7 in there. And then our maximum, 42.9. All right. So now we've got number 9 taken care of. We've got our minimum and maximum temperatures. Now we need to determine the slope of each graph. This isn't the best statistics to do for this, but never hurts. Gives us an idea about how much this is changing every minute or so. Kind of gives us a rate of change. So select a section near the right side of the graph. Well, I'm not going to worry too much about that. We're just going to do the whole graph. But we're going to click on the graph tools again. We're going to go to the curve fit. We're going to select linear. We're going to click apply. Then record the slope for the line, or slope of the line, for both probes in the data table. So note that m in the equation and the list below it is the slope of the line. And then dismiss that statistics box. So let's go back over here. So we're back to our graph. We're going to go down to the graph options again, down here in the bottom left. We're going to go to apply curve fit. And we're just going to leave it as linear. Again, this is not the best option because of the shape of these graphs. Okay, really, this isn't a linear graph. It's more of an exponential type of graph, but it's okay. So again, all we did there is we went to graph options, go to apply curve fit, leave it on linear. Got a bunch of other options. Actually, I think this natural exponent fits better than the other, but it's all right. So we're going to leave it on linear. Say apply. And now we've got a line, approximate line for each of these graphs. And m is our slope, right? So y equals mx plus b. M is your slope. X is just your x value from down here. Y is your y value over here. And then b is like where this would cross the zero line, or where this line would cross the zero line. So we got m for the white paper of 0.2, let's do 3 decimal places, so 0.279. So we'll come back here, we'll go down to this, 0.279. So that means it's changing about 0.279, almost 0.3 degrees per minute. Okay, so that's what that means. Then we come down, that's this one down here. So now that we have the black paper up here, the slope for that is 0.644. So that means that the black paper is increasing about 0.64 degrees per minute. If you just round this off, this would be 0.3, 0.6. So basically, if this is 0.3 and this is 0.6, then the black paper is warming up twice as fast as the white paper. This would be 0.6, this would be 0.3, which rounded off to 1 decimal place. But anyway, that takes care of number 10 now. Now number 11, we need to export a PDF version of this graph and then attach it to this file. If you're doing the digital copy or if you're doing a paper copy, export the PDF, upload it to the assignment on Schoology, and then turn in the paper copy. So either way, you're going to have something turned in on Schoology. You're either just going to have the graph turned in on Schoology, or you're going to have this whole data sheet, if you're doing the digital copy, turned in on Schoology. So what we're going to do, we're going to come back here. We're going to take some of this off of here. Tell you what, I'm going to leave the statistics on here, I think. Yeah, I'm just going to leave the statistics on there. Then we are going to export this. And, if you're on the online version, it's the same really as the offline version we were using. Just go up here to the file name. That says file menu if you hover over it. If you're in the offline version, it just doesn't have all of this up here. So we click on that. We say export. I'm going to say PDF. And fiddle with it here a little bit, see if we can get it to look any better. The statistics are kind of messing it up over here. So I'll tell you what, I'm going to turn the statistics off because they're going off the screen here and it's just cutting off a bunch of this. So we're just going to go ahead and do that. Get rid of the statistics. Okay, so we're just going to basically export this graph. You can go ahead and change colors if you want. You can click on your y-axis over here and change colors and stuff, but this is kind of what we defaulted to in class. So we're going to go up to the file name, go down to export. going to say PDF. And we're going to save that PDF. And that already opened that in preview. I want to put this somewhere I can find it. We'll call it radiant energy. And let's see here if I can find, yeah, work done together. Actually, so you could just download it to the downloads and go from there with it if you want to. I'm just trying to put it somewhere I can find it later. There we go. Okay, so you got your graph. So once this is exported, you're going to either upload that to Schoology or attach it. And again, all we did was from, this is the online version, but this works in the same in the offline version. Go up here to the file menu, click on that, go down to export, call it PDF, hit save file. It's probably going to save it to your downloads as like PDF export or something like that. Then you can move it from there wherever you want to, or just leave it there and go to Schoology and upload it. Okay, if I can get back to my file. There we go. So I'm going to attach it to this. So if I take the PDF copy, I go down to the very bottom. So if you're doing the PDF copy and you want to attach it, go down to the very bottom, go up to the edit menu. So under edit, go down to insert, page from file, find that file, which is fifth period, radiant energy PDF, and there it is. So now it's actually attached to this, like a little lab report. You know, you got all your instructions, you got your questions, you got your data tables, you got your graph. It's all in one spot. It's all in one big file now. Okay, so that gets us down to the point of really answering some questions. Okay, so questions, not super complicated. So calculate the temperature change. It's our delta T. Delta means change, and T is usually temperature. So that little triangle is a delta. But delta T is a change in temperature for each color by subtracting the minimum temperature from the maximum temperature. So you're going to take the minimum, subtract that from the maximum. So delta T is equal to T max minus T min. Then you record that value in your data table. Okay, so 32 minus 22 is 10. Okay. So our delta T here on the white paper is 10 degrees Celsius. Then, if we take the next one, let's see, 9 minus 7 is 2. Then 2 minus 2 is 0. 4 minus 2 is 20. So this would be 20.2 degrees. Plug that in a calculator if you want to. Okay. So that's our data table. So number one, you could, if you want to, say C table. Done. Okay. Now the rest of these are really pretty simple questions, honestly. So which color had the larger temperature increase? Well, if you look at these, the black paper did. So the black paper had the larger temperature increase. All right, which one had the smaller temperature increase? Well, that would be the white paper. Okay. So the white paper has the smaller temperature increase. So then what color clothing would be best to wear in the summertime, and explain? People always miss this explain part here. So I usually end up having to underline that when I go to grade stuff because people won't explain. So make sure you explain it, right? So you could say white or light colors. Okay, that's the first part of it, right? That's because they do not absorb as much heat as shown by the white paper in the data. So these questions, you always want to kind of, I know we have some common sense or we have some experience that yes, lighter colors aren't going to absorb as much heat, etc. But you always want to refer it back to your actual data. So you actually want to refer back to whatever your actual data is. So in this case, yeah, the white paper did not get us warm. Okay. Now down here, the next one, solar collectors can be used to absorb the sun's radiation and change it to heat. What color would work best for solar collectors? Explain. Again, explain. Don't forget to explain. But we can kind of look at this and say, well, if we're trying to turn sunlight into heat, black or other dark colors would be our best option. Why? Because it heats up more and it heats up faster, right? This is showing it heats up about twice as fast. This is just showing it heated up about twice as much, really. So, oops. There we go. Let's move that down there. Okay, so we could say black or dark colors. Really, black's probably be a better option for this. Because okay, so I kind of worded this weird, but black because black absorbs more heat from sunlight or converts more sunlight into heat, because visible light is not heat. It gets converted into infrared when it's absorbed. So anyway, so black or dark colors because black absorbs more heat from sunlight or converts more sunlight into heat. As shown by the black paper data. Black also heats up faster. Throw that in there too. Okay. And that's pretty well it. Okay, we're not going to worry about the extensions down here, so don't worry about these. We're just going to mark those off there. Don't worry about those. Okay. And then that's it. So don't forget then, if you did the PDF copy, you should have your graph attached. If you did the paper copy, the graph should be submitted to Schoology. And then the paper needs to be turned in whenever we get back to school.